Hello and welcome to the second video in a series of videos on differentiability. So last time, diniscuss natin yung intuitive notion of differentiability. Ngayon, ang gagawin natin is we will now give a formal definition of differentiability. Makikita natin mamaya that this formal definition is quite complicated. Hindi siya kasing simple nung sa one variable case. So we will also discuss some theorems that can help us deduce whether a function is differentiable or not. Magsimula tayo sa formal definition. Okay? So sa one variable case, pag sinabi nating differentiable si f of x, ang ibig lang natin sabihin nun ay f prime exists at that point. No? Sa function f of xy, differentiable tayo at the point AB. Unang-una, kailangan yung partial derivatives nag-exist dun sa mga point na yan. Dun sa point na yan. Okay? But that's not enough. Yan yung nabanggit ko dun sa huling video. Okay? There's a third condition where the limit of this mysterious limit must be equal to 0. This limit, the expression inside, pag tinignan nyo sa simula, parang ang pangit, no? But actually, kung maintindihan natin yung ibig sabihin niyan, hindi naman siya ganun kahirap. Okay, we will explain the meaning of this expression in a later video. Okay. So sa ngayon, tanggapin muna natin na may third condition na ganyan. The explanation will come after we discuss yung mga tinatawag na tangent planes. Okay. So there are three conditions para masabi natin na function is differentiable at a point. No? Yung dalawang partial derivative nag-exist, tapos itong limit na to dapat equal to 0. Okay. Sabi ko nga kanina, mahirap yung condition on differentiability. Meron tayong mga theorems to help us know whether a function is differentiable or not. So halimbawa, we have this following theorem. If a function is differentiable at a point, then it must be continuous at that point. Alam na natin yung one-dimensional analog nito. No? Kapag y equals f of x, we know this theorem. So totoo pa rin to for f of xy. And you can also kung aalalahanin niyo yung intuitive notion of differentiability, di ba sabi natin differentiable kapag zinum mo mukha siyang plane. So kung mukha siyang plane, ibig sabihin continuous siya. No? So if a function is differentiable, ibig sabihin continuous siya. So we will not give the proof. Okay, the proof is usually discussed in a higher division math course. Okay. Pero gamit tong theorem na to, pwede na nating malaman kung kailan hindi differentiable ang isang function at a point. No? So, syempre, kapag may hindi na satisfy sa definition, automatic hindi na siya differentiable. Okay? So, if fx or fy evaluated at AB, if either of those hindi nag-exist, hindi na agad differentiable. Or kapag yung limit na nakita natin kanina hindi nag-exist, or hindi siya 0, automatic hindi na siya differentiable. But because of this theorem, meron tayong fourth condition. Pag tinignan yung contrapositive, pag hindi continuous ang function sa point, ibig sabihin hindi siya differentiable dun sa point. So usually, madali lang naman ma-check yung fourth condition. So the fourth condition is a good test to show that something is not differentiable. Okay? So just check if it's not continuous. Tapos, paano naman natin malalaman kung differentiable ang isang function? There's a very useful theorem, and most of the examples or most of the functions that we will encounter in this course ay nasasatisfy yung premise ng theorem na to. So, anong sabi sa theorem? Kapag daw lahat ng first order partial derivatives of f ay nag-exist at continuous, automatic differentiable. Okay? So, if fx and fy are continuous at the point, differentiable siya dun sa point na yan. Okay? So, karamihan ng function na makikita natin sa course na to, continuous yung f sub x at saka f sub y. So, differentiable yung mga function na yun. So, as an example, halimbawa, tingnan natin kung differentiable yung mga sumusunod sa origin. Okay? So, for the first one, meron tayong f of xy equals e to the xy. So, una muna, papakiramdaman nyo kung differentiables or hindi. Itong e to the xy, magandang function yun. Exponential, tapos mga polynomial ang involved. So siguro kung papakiramdaman natin, mukha siyang differentiable. Okay? Tapos sa diniscuss natin, pwede natin i-prove yung differentiability either by definition, pero parang naka-stress yan, no? Kasi may limit, may pangatlong, to sa definition, may third condition about the limit. Or you can just use yung theorem na to. Tingnan natin yung mga partial derivatives niya. Tingnan natin kung continuous sila. Okay? Pag nangyari yan, differentiable na tayo. So pag kinumpit niyo fx and fy, ito yung mga makukuha niyong function. So y e to the xy and x e to the xy. And obviously, they are continuous at the point 0, 0. Right? Actually, they are continuous everywhere. So dahil continuous siya sa origin, differentiable na siya sa origin by the theorem. As another example, halimbawa, pag tingnan natin itong piecewise function, it is 0 sa lahat ng point not equal to the origin. Okay, pero pagdating mo sa origin, yung value mo ay 1. So kung isipin nyo yung graph niyan, parang yung flat plane, pero sa origin, nakaangat yung isang point na yung z value niya dun ay equal to 1. So again, obviously, this is not continuous. So discontinuous yung function natin. So by this fourth condition, sabi pag hindi continuous, automatic, hindi na siya differentiable. So ang conclusion natin ay the function is not differentiable at 0, 0. Okay. Dun sa intuitive notion natin, binigay natin itong example na f of xy equals x to the 1/3, y to the 1/3. Ipapakita natin ngayon that the partial derivatives exist at the origin, pero hindi siya differentiable. Okay? Alam na natin na hindi siya differentiable from the intuitive notion. Okay? Pero pakita natin na yung mga partial derivatives nag-exist. Ang point na example na to ay para ipakita na hindi talaga enough na nag-exist lang yung partial derivatives para sabihin differentiable yung function. Hindi siya ganun kasimple. We really need the third condition here. Yung may ugly limit. Kailangan talaga natin yun. Okay. So let's compute. Yung fx of 0, 0, according to the alternate definition, equal yan sa limit of f of x0 minus f of 0, 0 divided by x minus 0. As x approaches 0, right? Tapos pag tinignan nyo itong f of x0 and f of 0, 0, parehas siyang mag-equal to 0. Okay, so this one is 0 and this one is also 0. So yung numerator natin ay always equal to 0. So 0 divided by any non-zero number is going to be 0. So ang limit ng 0 ay 0. And also similarly, you can check ang fy of 0, 0 ay equal din sa 0. So nag-exist sila. Also, by the way, baka kasi may gumawa sa inyo ng kukomputin nyo muna yung fxy using techniques of differentiation. So, pwede yun. Pag dinifferentiate nyo yung f with respect to x, ang lalabas ay 1/3 x to the minus 2/3 y to the 1/3. Kasi yung y natin is a constant. So, this is the same as y to the 1/3 over 3x to the 2/3. Pero baka pag tinignan nyo yan, pag nag-plug in kayo ng x equals 0 and y equals 0, makikita nyo magiging 0 over 0. So bakit ganun? Pero na-compute natin na partial derivative ay equal to 0. Pero parang pag tinignan mo dito, mukha siyang indeterminate. Ang dahilan kasi kapag magko-compute kayo ng partial derivative, hindi natin sabay pina-plug in yung mga variable. Remember, kapag nagko-compute kayo ng fx, ginagawa natin sa pinakasimula pa lang, we are fixing y. Okay? So we fix y equals 0. So una tayong magpa-plug in ng y equals 0 bago yung x equals 0. Hindi pwedeng sabay. Okay? In most cases, hindi nagmamatter kung una mong i-plug in yung y or yung x. Pero may mga examples katulad nito na kapag sabay mo silang pinag-in, wala kang makukuha ng sagot. Pero pag inuna mong pinag-in yung 0, ang lalabas 0. No? So kapag kinuha mo yung fx of 0, 0, ang makukuha natin ay 0. So consistent pa rin siya doon. Okay? Now, bakit hindi siya differentiable? Well, the answer lies in the third condition. No? Sa third condition, merong r of xy na dinefine. So, nilagay ko ulit siya dito. So, r of xy is this long expression here. Okay. Kung ang f of xy natin ay x to the 1/3, y to the 1/3, tapos yung ab natin ay yung origin, dyan tayo nag-check ng differentiability. Nakuha natin from the previous slide na yung mga partial derivatives ay 0. So, itong part na to, tsaka part na yan, parehas yung 0. So, mawawala lang yung term na yan. And also, f of AB, right? F of 0, 0 is equal to 0 then. So, itong r of xy natin is just x to the 1/3, y to the 1/3. Parehas lang siya nung f of xy. Therefore, ano yung limit na kailangan natin computin? So, sabi dun sa definition of differentiability, we have to compute for this limit. Okay? Dapat equal siya to 0. Pero yung capital R natin is equal to x to the 1/3, y to the 1/3. And A here and B are both equal to 0. Ito yun. So, pag sinolve niyo yan, magiging limit ng delta x to the 1/3, delta y to the 1/3 over the square root of delta x squared plus delta y squared. As delta x, delta y goes to 0, 0. Okay, and then I'll just leave it as an exercise to show that this limit does not exist. Halimbawa, you can show na as delta x, delta y goes to 0, 0 along the line delta x equals delta y, ang lalabas na limit along that curve is infinity. So, hindi nag-exist. Okay, so meron tayong isang path na wala tayong limit. So, therefore, yung buong limit hindi na agad nag-exist. Okay, so na-fail niyang masatisfy yung third condition that the limit of this expression equals 0. No, hindi yan nag-equal to 0. So, this function is not differentiable. Okay? So, this is how you formally prove that f is not differentiable at 0, 0. Okay. So, for this video, we gave a formal definition of differentiability. It has 3 parts. Okay, the first 2 parts deals with the existence of the partial derivatives, and the third part tells us that the limit of this mysterious expression must be equal to 0. I-describe natin in a later video kung anong ibig sabihin ng expression na yan. But we also describe some theorems that can help us deduce the differentiability and non-differentiability of our function.